Ward. I'm the Policy and Communications Director at the Grantham Research Institute on Climate Change and the Environment at LSE, and it's my pleasure to welcome you here for tonight's lecture. It's a public lecture by Professor Lord Stern of Brentford, or Nicholas Stern, known to most of you. Let me just start with a couple of housekeeping points. If you haven't already done so, please turn off your mobiles, pagers, iPods, personal DVD players, anything else you might have on at the moment that might disturb. I'm going to run through the schedule. Nick's going to talk for about 40 minutes. Then we'll go to a Q&A session where we'll take any questions from the audience. You'll be asked to identify yourselves, and I'll remind you of that later, and wait for a microphone. Following the Q&A session, we'll have a book signing. So you can see outside there's an opportunity to buy the new book, and Nick will be in here to sign copies as well. So Nick hardly needs any introduction, but I'm going to give a short one anyway. He's had a very distinguished career in academia, in bodies such as the World Bank and the European Bank for Reconstruction and Development, and from 2003 in the UK government. Between 2003 and 2007, he was head of the UK Government Economic Service, and among other duties during that time, he was, between 2005 and 2007, advisor to the UK government on the economics of climate change and development, during which time he authored the landmark and report on the economics of climate change, or the Stern Review, which you no doubt have seen. In June 2007, he returned to LSE, where he was the Sir John Hicks Professor of Economics between 1986 and 1993, and he became the first I.G. Patel Professor of Economics and Government. He also directs the Asia Research Centre and the India Observatory here. He's chair of the Grantham Research Institute on Climate Change and the Environment, and he's also chair of the Centre for Climate Change Economics and Policy, which is jointly hosted by LSE and the University of Leeds. Tonight he's going to give his first public lecture about his new book, A Blueprint for a Safer Planet: How to Manage Climate Change and Create a New Era of Progress and Prosperity. Since it was published on 2nd of April, it's had glowing reviews in The Guardian, The Sunday Times, and The Telegraph, amongst others. So looking forward to hearing from him. So please welcome Nick Stern.
Thank you all very much for coming. It's a great pleasure for me always to lecture here in the old theatre. In the 80s, I used to, probably some of you, I used to lecture on microeconomics theory to second years, trying to tell people about market imperfections, most of which they promptly forgot and started making lots of money in the city. I've been back here for 2 years. It's been a real pleasure, and every day I enjoy myself walking, when I'm not travelling around trying to persuade people to change the world. When I'm here every day, I get great pleasure about what a special place LSE is. So thank you all for coming here. Now, it's 2.5 years since we published the Stern Review. A lot's happened since then. Looking back, I think that I underdid the damages. I think the world is more risky than we articulated at the time of the Stern Review. Emissions are growing faster, the planet is absorbing less than we had imagined, and some of the effects are coming through faster. Some of the effects relating temperature and climate outcomes are coming through faster than we thought. On the other hand, I'm more cheerful in the sense that the understanding of this issue has deepened greatly and broadened greatly over the last 2 or 3 years. And the technological change that we're seeing is much stronger than I think we dared to anticipate. So the problem is more worrying, but I think our ability to respond has strengthened. We now have to put together a global agreement in the next precious few months between now and Copenhagen at the beginning of December. We're already at the end of April. The Copenhagen discussion, the 15th Conference of the Parties of the United Nations Framework Convention on Climate Change, to give it its full title, will be meeting to try to put together a global agreement at the end of this year under the chair of Denmark. It's a huge challenge to get from where we are now to get to a substantive agreement. We have to understand the problem, we have to understand what we can do about it, and we have to understand the roles of the different players. And that's what I've tried to set out in the book that was published a couple of weeks ago. But in order to get to a description of a global deal, and I'll argue that that global deal has to be effective in terms of the scale of the emissions cutbacks, it has to be efficient, we have to do this as cheaply as possible, and it has to be equitable across a whole range of parties that are involved, particularly developing countries. Such a global deal has to be set out and understood and discussed, and this is the purpose of what I've been trying to do, but you have to understand what underlies it in terms of the science and economics before we can understand what kind of global deal we ought to be trying to put together. So the second half of what I have to say will be about the substance of the global deal, but the first part will be describing the science and economics of the problem, which underlies the description of the global deal. One can't understand why you'd want a global deal like that unless you'd done the foundations on the science and economics. So that's where I'll want to begin. I'll have to go fairly rapidly because what I've already described is a very big story. The science is big, the economics is big in terms of substantive argument and analysis, and of course the details of the global deal are quite substantive too, so there's a lot to go through. So excuse me if I go fairly fast, and excuse me if I have to be fairly superficial at some points. Those of you who want to go through the argument in a bit more detail can look at least I hope you will buy the book. And those of you who want to go into the nerdy economics of all this can look at my paper in the American Economic Review of May 2008. The first thing I did after I left government was sit down and write it all out in much greater detail for my fellow economists. So those of you who like the mathematics and the numbers can look at the American Economic Review Papers and Proceedings, May of last year. So let's get on with the story. Now, I came into this as someone who spent a lifetime working on economic policy, particularly on the economics of developing countries. That's still the way I come at this story. The two defining challenges of this century are overcoming world poverty and managing climate change. We succeed or fail on those two defining challenges together. If we do not manage climate change, we will undo and set back the progress that's been made on development, and we will make further progress extremely difficult and indeed, in many parts of the world, impossible. If, on the other hand, we try to manage climate change by putting barriers to the growth in incomes in developing countries over these next 2 or 3 decades, we will not put together the global coalition that we need, and we will not deserve to put together the global coalition that we need. We succeed or fail on these two things together. Now, many of you will notice that we also have an economic crisis, and I will say towards the end how all this fits in to that story as well. I want to argue that we can and should tackle all these three things together. The economic crisis is shorter term and of a smaller magnitude than the other two crises, even though it's a big economic crisis, and let's not underestimate its severity. But the other two are still more important. But I don't want to set any one of these three against the other, because I think we can and should manage all three together. So that's, roughly speaking, the storyline. So let's get down to work. The first thing to recognize, because everything else follows from it really, is the process by which this whole story functions, of the relationship between what we do as human beings to the planet and how that comes back at us in various forms. And the story is quite a simple one. 5 simple links in a chain. The first one is from people to emissions. In our basic activities in life, whether it be consumption or production, we emit greenhouse gases, particularly, of course, if we use hydrocarbons, particularly if we use hydrocarbons inefficiently, and particularly if we destroy our forests. But through normal activity, one way or another, we emit greenhouse gases. That's the first thing, from people to emissions. That's a flow. Think of it as an annual flow. The second step is from emissions to concentrations of greenhouse gases in the atmosphere. It's the link between the flow and the stock. The planet cannot absorb all the emissions which we make, and that means that the concentration of greenhouse gases in the atmosphere goes up. That's the second link in the chain, from the flows to the stocks. Now, it's the concentration of greenhouse gases that catches the infrared, stops it escaping, and results in global warming. That's the next link in the chain. That's the standard greenhouse effect. It's the concentration of greenhouse gases that catches the heat, just as the glass in the greenhouse catches the heat. But it's not so much the heat that's the problem. It can indeed, heat stress can occur, growing seasons can change, and all this can disrupt agriculture. But mostly this is about water in some shape or form. Storms, floods, droughts, sea level rise. That's the way in which this happens. That's the climate change. So it's global warming to climate change, which is a key link in the chain. And global warming is not really a particularly good shorthand for the phenomenon. Climate change is better, but even that obviously doesn't capture. The last election I thought was about change you could believe in, and going forward, and yes we can and all that, in the United States. So climate change, you say, well, what's the problem? Well, it changes in a very hostile, damaging way, and that's the last link in the chain from climate change back to people. And what we do and what we are doing is creating and will create a very hostile physical climate that will, if we don't do anything about it, of course I'll argue that we can and we should, but if we don't do anything about it, it will stop growth and development from whatever kind of dimension you think about it in its tracks. So that's the basic story. This is a story in economics terms of externality, of people's actions affecting production and consumption possibilities of other people, or living possibilities of other people. It's an externality. Like driving your car and slowing people down is an externality. We think of that as congestion. Sooty emissions from chimneys in London prior to the 50s and 60s, when we introduced the Clean Air Act, was another example of an externality. But this is a much more difficult one. It's a much more difficult one, first because it's global, not local. It doesn't matter where the greenhouse gases come from. Secondly, it is long-term. And people don't, when you are slowed down by traffic in front of you, you know what's going on. In this case, the effects manifest themselves with quite long lags, so it makes the politics of all this much more difficult. These changes are enormous magnitude. It's not just being slowed down in some city or other. This is changing the world as a whole on a huge scale. The magnitude of this story, and I'll come back to that, is very big. And finally, it's full of uncertainty. Any policy that we talk about has to be constructed in the face of very big uncertainties. We know there's an underlying trend because there's very simple science that tells us there is in increasing temperature and thus climate change as a result of the activities. But there are all kinds of uncertainties and oscillations layered on top of that, partly real oscillations that take place in the way the world functions, but also lots of uncertainty about our ability to predict what might happen. So those 4 elements that I've just described make this an externality unlike any other. So very simple-minded policies, such as a price for carbon and then stop, is not going to be good enough. Price of carbon is going to be absolutely fundamental. People have to be faced with the cost of the damages they do. This is the biggest market, without corrective policy, this is the biggest market failure the world has ever seen. And we have to begin by correcting that market failure, pricing properly for the externality in the language of economics. But this is a sufficiently complex problem that won't be enough. And I'll come back to some of the specifics of what we have to do. So that is basically the storyline. Now, so the first link in the chain is from people to emissions, and in the diagram here, I've illustrated where, in terms of geography, most of the emissions come from. Now, you'll have to buy the book and get your nose into it to be able to read that properly, but all the diagrams do come from the book. But the point is a fairly simple one. It's a few major countries that are responsible for most of the emissions. Which countries? Well, countries with lots of people, of course. Countries where they are using energy very intensively and using lots of hydrocarbons. That's particularly rich countries, United States and European Union, of course, being very important, and countries where deforestation is a big issue. Brazil and Indonesia being the biggest of those. So one way or other, you've got big countries, you've got rich countries which use a lot of hydrocarbons, often inefficiently, and you've got the countries where deforestation is taking place. And that's the 6 or 7 countries responsible for most of the emissions. But of course, we shouldn't simply look at it country by country. This is also about different kinds of country in terms of standard of living. Now, what this diagram tells us is on the vertical axis, you've got CO2 emissions in terms of tons per capita now. And you've got rich countries at the top, and in that black line and in the grayer line, you've got the poorer countries. So you can see, looking at CO2 only now, I've switched to CO2 only because putting time series together for CO2 equivalent is a bit tricky. The difference between CO2 and CO2 equivalent is the other greenhouse gases. So most of my time I'll be talking about CO2 equivalent, putting all the greenhouse gases together. But for this diagram, because I wanted a time series, I've had to revert to CO2. But basically, for rich countries, you see an average of around 12, with a slight fall in the last 30 years or so. In the poorer countries, you've got an average which is around 4 tons per capita, which has come up quite strongly from 30 years ago when it was less than 2, and been accelerating in the last few years. And that's growth in the developing world using the kinds of technologies which powered the growth in the rich world. So that's not particularly surprising. It's just a reflection of the very welcome, more rapid growth that we've seen in many developing countries. But this is a very important graph because it tells you that there's a great inequity here. Rich countries are emitting much more per capita than poor countries. In the past, if you look back, probably 60, 65, 70%, depending on how you do the sums, of the concentrations of greenhouse gases in the atmosphere now come from the rich countries. On the other hand, it's the poor countries that get hit earliest and hardest. At the same time, emissions are growing very strongly in poor countries. By 2050, there'll be 8 billion of the 9 billion people in the world in 2050 in the currently developing countries. And unless they are central to the deal, we are absolutely not going to be able to cut emissions on the scale that we must. So this is going to have to be a global agreement where we're all involved. But the inequities of history have to be part of that deal. And so too does the recognition that it's the poorer countries that are going to be hit earliest and hardest. So that's crucial background to understanding the shape of the global deal. Now, this is the key diagram in understanding the way I think we should approach the problem. So let me spend a moment or two explaining it. Down the left-hand side, you've got stocks of greenhouse gases, concentrations in the atmosphere measured in terms of parts per million. We're currently around 435 parts per million. So if we manage to stabilize that, say at 500, then the probability of going above 3 degrees centigrade would be below a half at 44%. On the other hand, the probability of going beyond 2 degrees centigrade would be pretty high, 96 degrees. If we didn't act and let things go, and the concentrations of greenhouse gases got to 750, yet we managed to stabilize there, then the eventual temperature increase, the probability of being above 5 degrees centigrade would be close to a half, 47% here. Now, these are not my numbers. These come from what I think is arguably the best group on the modelling and science of climate change in the Hadley Centre in the UK. But they're not dissimilar from other kinds of measures of probability of going above certain temperatures. Indeed, there are a number of other models which actually put the probability of higher temperatures still higher than the Hadley Centre model. So this is not me doing economics. This is myself as an economist trying to get the input from the science on risk management, because a lot of economics is about risk management, and I think the right way to think of this problem is indeed in terms of risk management. Now, where are we? We're at 435 parts per million, roughly. We're adding 2.5 a year, and that 2.5 we're adding a year is rising. If we didn't do very much for the rest of this century, then we would be adding 3.5, 4 parts per million a year. If you run that forward through the century, then probably we would be adding something over 300 parts per million from business as usual, perhaps more, during the course of this century. That would take us from where we are now at 435. If we'd add 300 plus, it would take us close to 750. Arguably, it would take us beyond. How would that position us? Well, it would give a roughly 50% probability of being above 5 degrees centigrade. Now, if you're in Moscow in February, that might not sound like a bad idea. But what does it mean? Well, it means a transformation of the planet. We have not seen those temperatures for 30 million years, the Eocene period. We've been around as human beings for 100,000. If you're very generous about the definition of a human being, maybe 200,000. But you're comparing that with 30 million since we've been at 5 degrees centigrade. We don't know really how humans could handle this. They probably, many of them, couldn't handle it at all. It would be mass movement of species. Being lower temperatures, having glacial periods, of course, is much more common. And we'll probably have another ice age in a few tens of thousands of years. And we had our last ice age very recently, 10 or 12,000 years ago, when there were indeed quite a few humans around. And what did people do? Well, they lived closer to the equator than where the ice sheets came. Those of you who measure everything in relation to Watford, they live roughly south of Watford. And that's because they're sensible and you can't do much where there's lots of ice, so that's where they were. This involves movement of people on a massive scale. 5 degrees centigrade is very hard to picture, but it would surely rewrite the physical geography of the world and thus the human geography of the world. That means where we can live and how we can live our lives. And it would happen fast in historical time. It would probably happen in 100, 150 years. It wouldn't just happen suddenly, we'd be moving there. And that's incredibly rapid change. It would be handled by lots of people moving. I mean, handled is barely the right word, but the response would be lots of people moving, hundreds of millions, probably billions, and that would involve extended conflict on a global scale. All this is probably. But probably is enough to make us worried. And I'm talking about probably more than 50% probability. This isn't the small probability of something pretty unpleasant in a few hundred years. This is a large probability of something catastrophic in 100 or so years, with a lot of parts of the story coming through faster than that if we're not sensible. So the magnitude of the risk we should be clear on. So what I'm arguing here is that we should see this as a risk management problem. We should try to force ourselves up into the 450, 500 maximum as an upper limit, and then start asking ourselves a question of how we can get it going down from there. Because we probably shouldn't be satisfied with 500 parts per million. We should ask ourselves the question, can we bring it down from there? But we certainly can't hold it below 450 parts per million. We'll be at 450 parts per million in 6 years. That's before England gets the World Cup in 2018. This is, we have to beat off another 8 competitors, but the time scale here of 450 is upon us. I mean, we're going to be at 450 very soon. But we have a decent chance of holding it below 500, and then we have to ask ourselves the question, how do we bring it down from there? And that is another set of questions which I think is very important. So that's the challenge. That was stocks, that was concentrations. If we're to hold it below 500 and then to start bringing it down from there, what do we have to do? Well, blue line is business as usual on emissions, and the red line is one that can bring us down to, or hold below 500. So if we're to hold below 500, we have to cut emissions from the roughly 40 gigatons that they were around 2000, around the turn of the century. They were fairly similar in 1990, and often people use 1990 as the baseline, but aggregate emissions were roughly the same 1990-2000. Different countries' emissions, of course, very different, but aggregate about 40 in 1990. So we have to bring it down from about 40 down to about 20. So that's why we talk about 50% reductions by 2050 relative to 1990. This is where it comes from. It comes from a notion of the dangers associated with letting concentrations go any higher than 500. That's the challenge. And that's a very important number. We've got to get down to 20 gigatons at the highest by 2050 as a world. That means that emissions per capita as a world should be around 2 tons. We will be about 9 billion people. If we're emitting 20 gigatons as a world, then 20 divided by 9 is just over 2, remembering that giga and billion are the same. You may just have heard that giga and billion are the same, but otherwise you remember. The scientists use giga and the economists use billion, but they're the same thing, 10 to the 6th. So what we've got here then is a very clear story that we need to get down to no more than 2 tons per capita on average as a world, to roughly 20 gigatons, as a maximum by 2050. And we have to remember that we in the UK are a little over 10, 12, most of Europe 10, 12, United States over 20, Canada, Australia over 20. So United States ought to be dividing by 10, we ought to be dividing by 5, and that's the 80% reduction. So why do people talk about 80% reductions, 1990 to 2050? It's not a number plucked out of the air. It comes from this logic of needing to get average emissions down to around 2 tons per capita. And there won't be many people below 2 tons per capita, so there can't be many people above 2 tons per capita, because the average is the average. You learned that before you got to LSE. So that's why we talk about those kinds of numbers. That's where they come from. They come from this kind of risk analysis. But of course, you can't just sort of set targets without asking what it's all going to cost. And that is a very big part of the story, and how you achieve those reductions. Well, how do you achieve those reductions? At one level, it's straightforward to describe. You're much more energy efficient, you have to have low carbon technologies, and you have to stop deforestation. And you have to do that everywhere. If you leave big parts of the world out, you won't get there. If you leave big activities out, you won't get there. You've got to, across the board, go for greater energy efficiency whilst you're still using hydrocarbons, and then develop the low carbon technologies and halt deforestation. We have to have close to zero carbon electricity by 2050 around the world. And it's not mysterious about how we do that. We know lots of ways already of having close to zero carbon electricity, wave and solar and wind and nuclear. There's a whole range of technologies, and we'll have to look at them all to see how they perform. Each one of them has its problems, and we're going to have to think those through. Each one of them has its costs, and we're going to have to think those through. Each one of them combines with others in different kinds of ways. This is the kind of work we have to do. But we can recognize how it's done. We can recognize already what many of these low-carbon technologies look like. If you've got zero-carbon electricity, then you've got zero-carbon surface transport. And maybe eventually, if we're clever, zero-carbon air transport. But it may be biofuels that we'll need for the aeroplanes. But we're going to find that out because we have to. And that's the kind of work that we have to do. But we can see roughly what it looks like in terms of technologies. It's going to be much more public transport and much less private transport. It's going to be designing cities in a way that operate much more efficiently, and buildings that operate in ways which run themselves. There are all kinds of, without major hydrocarbon inputs. There are all kinds of things we can point to that we can already recognize. So it's not a mystery as to whether we can get there, but there is a question of getting there as cheaply as possible. And of course as attractively as possible, not necessarily just the cheapest way. It's also what's attractive in getting there. Now what's it going to cost? Now this is an illustration of some of the costs which comes from McKinsey. Now I'm not asking you to read the very small type. The point is, first, that there are lots of options which have negative cost. That's energy efficiency. Secondly, is there's lots of options. There are lots of ways of doing it, and we must investigate them all. Thirdly, policy matters, because policy will guide us towards different options. Economists like me like the price mechanism, and if we get a price of emissions right, then the competitive processes will seek out the cheapest ways of doing things. But we're in a hurry, and there's lots of uncertainty, and some markets don't work well. So there's going to have to be a fair bit of regulation, and some of this can only be done in a communal way. You can't have combined heat and power other than in a community. You can't reuse and recycle other than in a community. So a lot of this is going to be how we think about how communities work. But what we're seeing here is there are lots of options. There are lots of options that save money. We won't do it only by using those options. We're going to have to spend some money too. How much are we going to have to spend? Well, let's do a little bit of mental arithmetic. If you go back to this diagram, we're going to have to take out, relative to some notion of business as usual. You can invent all different notions of business as usual, but just to give one example is the blue line. We'd have to take out about 65 gigatons to get down to 20 gigatons in 2050. 65 gigatons. Suppose on average that cost us, you go back to these McKinsey diagrams, suppose on average that cost us about $30 a ton. I've actually got euros on the vertical axis here, but don't worry about that. Who knows, maybe by 2030 the euro and the dollar will be one for one. That's not the kind of thing that we're placing great emphasis on right now. Suppose then you took out 65 gigatons and it cost you $30 a ton. Well, you can all multiply 65 by 30, yeah? And then provided you get your noughts in the right place, you can work out what it costs you. So 65 billion tons at $30 a ton is 1.95 trillion tons. Yeah? You can all multiply 65 by 3 in your head to get to 195. The rest is just the decimal points in the right place. It's $1.95 trillion. GDP, if we're sensible, if we're daft, of course, GDP might fall, might be lower in 2050 than now. But if we're sensible and follow these kinds of policies, GDP might double, and that would be $100 trillion in 2050. So 1.95, roughly 2, in $100 trillion, roughly 2% of GDP. So that gives you a little feel of how you do these sums. Now, I have two views of these kinds of sums. One, if you can't do the mental arithmetic, you should be suspicious. And two is that you shouldn't only do the mental arithmetic, and you should go and dig and work out and do your calculations in some detail. But roughly speaking, most people who've done that have come up with numbers that are a good deal less than 2% of GDP. The International Energy Agency, a good deal less. McKinsey, a good deal less. I've allowed for things to go wrong in doing this calculation like this. I've allowed for not very good policies. There's a fair bit of flab in my number. I do think that we should be optimistic about technical progress, and that will bring costs down as well. So my guess is that 1 or 2% of GDP may well turn out to be on the high side. It may well be only for 2 or 3 decades. After that, technical progress may have got to such, given us such results that a lot of our new ways of doing things are unambiguously cheaper than the hydrocarbon alternatives, particularly if hydrocarbon prices go up, of course. So it may be less than that, but I think we have to be honest with ourselves. And I argued in a piece in the Times today that a bit of candidness about the costs over these next few decades was welcome, and we'll wait for the budget tomorrow. But that is the kind of insurance premium for a few decades that we pay to reduce these enormous risks very, very substantially. But we get more than that. We get the engine of growth over the next 2 or 3 decades. Low-carbon technologies are going to be like electricity, like railways, like IT, as technological drivers of growth. And we'll be investing in this growth story. We'll be having a story of growth. High-carbon growth kills itself. First on the high price of hydrocarbons, and secondly on the very hostile physical environment that it creates. So this is actually a growth story, and we need a growth story if we're going to deal with the other and crucial defining challenge of this century, which is overcoming world poverty. I don't think that we as a world should contemplate growing forever. Forever is a very long time, and as Woody Allen said, particularly near the end. But do we need to grow as a world for the next few decades? I would answer that we do, if we're to overcome the challenge of world poverty. We've got to find a way of doing it that's different from the way we've grown in the past, and that's low carbon growth. And we'll find out that we get these endogenous growth stories, if you like that language, well, even if you don't like that language, for 20 or 30 years as we discover lots of things along the way. But we'll also find out that low-carbon growth story is much more attractive. As well as being a growth story, the other high-carbon growth cannot be a growth story for very long, but as well as being a growth story, it's more energy secure, it's more biodiverse, it's cleaner, it's quieter, it's just much more attractive. So here we have a story of something that can pull us out of a recession, deliver a growth story over 2 or 3 decades, take us to a pattern of growth which is much more attractive, and radically reduce the risks of climate change. We'd have to be mad not to pay 1 or 2% of GDP for a few decades to get there. Now, the human race is quite able collectively to be mad, but we should recognise that the arguments here, I do think, are overwhelming for strong, coordinated action now. So I've got to the global deal. So I'll spend the rest of my time, which isn't very much, but could I spend 10 minutes on the global deal? So 6 parts to the global deal. But I've actually told you a good part of it already. It's got to be effective, it's got to be efficient, and it's got to be equitable. 50% cuts overall, I've explained that. I've explained that that requires an average of 2 tons per capita for the world. I've explained that because we can't, not many of us will be below that, not many of us can be above that. And that given where the rich countries start from, they should have at least 80% cuts by 2050. That does not mean, and let me underline this, that does not mean that if we get there through market mechanisms and the allocation of quotas, that does not mean that rich country quotas should be 2 tons per capita. There's a lot of history in this of the stock and how we got where we are. There's a lot of here about inequality and who has the greater ability to contribute. My own view is that there should be naught allocations to rich countries for some considerable time. So because I'm talking about 2 tons per capita actual emissions in 2050 as a simple consequence of the arithmetic, please don't confuse that with an argument that quotas should be 2 tons per capita. I think that argument is wrong. Now, so that's the story of what rich countries should do, and they have to set strong examples. As ex-President Clinton said in the Democratic Convention, let us show the power of our example rather than the example of our power. You know, the gentleman has a way with words. And this is a story of example. The developing world has every right to say, you got rich on a high-carbon growth strategy. Please help us and demonstrate some examples of how to run a low-carbon growth strategy. Many of the examples will actually be developed in the developing world itself. But there is a challenge which I think to rich countries is fair, and to share the technologies that are developed and to contribute to finance of those new technologies as they're applied in the developing world. What about developing countries? Well, it's quite clear that this can't work unless developing countries are centrally involved. Even if rich countries were emitting absolutely zero in 2050, the average per capita emissions in the developing world would have to be 2.5. Divide 20 gigatons by 8 instead of 20 gigatons by 9. So unless the arithmetic is brutal here, unless the developing world is involved, it's going to be quite impossible to get there. And they're going to have to, all of us, everybody, get down to something like 2 tons per capita. That's going to be tough on China. It's probably tougher on China than anybody else in terms of technological and economic change, because China is already over 5 tons per capita. If the Chinese economy multiplies by 10 between now and 2050, which would be a significant slowing of growth, then in order to cut by 2, if the economy is growing by 10, you'd have to cut emissions per unit of output by 2 times 10. That's 95% cut in emissions per unit of output. That's a very big change. So the challenge will be to set examples, help with finance, share technology, so that the developing world can rise to those challenges, which are so important for its future. Now, my own view is that the structure of this deal should be the developing world explaining to the rich world what the responsibilities are of the rich world and how it, as a developing world, will act. This should not be a set of propositions hatched in the rich world and sold to the poor world. It should ideally be everybody getting together and doing it, not worrying about where you come from, but taking into account history and income and ability and technology and so on. But if there's to be any direction of striking of the deal, it should be that the developing world lays down the description and the conditions on the rich world, roughly as I've just described them. Third part of the global deal, and this is very important both for efficiency and for equity, is to try to get the price system to do its work in searching out the lowest cost way of doing things. Emissions trading schemes, I think, are a valuable way of doing it. Carbon taxes also have their role to play. And if you look at Europe, for example, we have heavy taxation, rightly so, on petrol. And we have the European Emissions Trading Scheme covering not that many industries, but around 40% of European Union emissions. We've got a combination of the two, and we will have regulations as well. We'll have regulations on car industries, we'll have support for technical progress. So we'll have a combination of instruments like that, but a price for carbon is absolutely fundamental. And coming through carbon markets derived from quota trading gives you a number of things which are of value in my view. They allow for buying outside the country, which A, brings costs down, but of particular importance allows the flow of funds to the developing world for investments which take place there. Having quotas gives you more confidence on the overall quantity, confidence that a simple price mechanism by itself could not bring to the same degree. There are attractions in the price mechanism. They're probably like a carbon tax, which is probably easier to administer in many ways, and I wouldn't want to set one horse against the other horse. But carbon trading, in my view, is going to have to be a big part of the story for the reasons I described of greater quantity certainty, and quantity certainty matters here. We're trying to bring the quantity of emissions down, and because they allow flows of funds across borders in ways which I think will be a very important part of the equity of the global deal. There are lots of complications in how these markets work, how the one-sided mechanism of the clean development mechanism, how that works, one-sided because you can get reward from cutting, but you're not penalised for going above, and we have to think about how to reform that system and then move beyond it to two-sided trading. But that's a lot of important technicality in there, but I haven't got time to go into that. But trading will be a big part of this story. Deforestation, absolutely fundamental, close to 20% of emissions. Deforestation does lots of damage, way beyond simply the climate damage in terms of soil erosion, destroying or disrupting very severely watercourses and water management and so on. Stopping deforestation is absolutely fundamental. It can happen, it's a tropical rainforest of particular importance here. It can only happen as part of a development story designed by the countries where the trees stand and supported by others. It has to be a development story. This has to be a story about alternative activities, more productive agriculture that doesn't require so much pressure on land and thus the invasion of the forests. It involves better governance so that you can have pricing policies and property rights associated with the forests. It's quite a complicated story, but it's a development story, and I think we're starting to make at least some progress on that, with probably Brazil leading the charge, and President Lula's Amazon Development Strategy and Amazon Fund, I think, are good examples as part of Brazil's climate change action plan. Technology is going to be of fundamental importance here. It'll involve using existing technologies and getting those deployed much more rapidly, and we know from experience that the costs come down as they're deployed. It'll involve investing in new technologies. Carbon capture and storage for coal-fired electricity will be absolutely fundamental. To the extent that if we can't do it well, we're going to have to focus, we're going to have to find out very quickly and put much more resources into other technologies. It's going to be so important because about 50% of electricity in the world comes from coal. And that will probably continue to come from coal in China and India and Poland and the US and other parts of the world for some time. So if coal is going to be used, the only response, because it's the dirtiest of all the fuels, we have to learn how to do carbon capture and storage, and we have to learn how to do it quickly on commercial scale. We know how to do it on smaller scale already. The question is, can we make that work on big scale? And we've got to find out quickly. If we can't, then it's plan B, and plan B will be more expensive probably than plan A. But there is a plan B. There are other kinds of technologies that we can use. But we have to find quickly whether it's going to work, and the only way we can do that is by getting on with it. That's why there shouldn't be any coal-fired power stations in this country, in Kings North or anywhere else, unless they have carbon capture and storage involved. We can't ask India and China to use new clean coal technologies if we're not prepared ourselves to demonstrate that they work and share those technologies. And if we find out that they don't work, then we concentrate our attentions on solar and wind and wave and nuclear and many other things that will have to be part of the energy mix in any case. Adaptation, and this is the last and sixth part of the global deal. Development in a more hostile climate is more expensive. It's as simple as that. But it's tough and it's difficult. And when we put together as a world financial packages intended to support the achievement of the Millennium Development Goals, which we did around the turn of the century, and I was involved as chief economist of the World Bank in the Monterey gathering, United Nations gathering on financing for development, and I was involved as I led the writing of the report of Commission for Africa, which went to the G8 in 2005. I can tell you, because I was directly responsible for this mistake, is not on my own, of course, that we didn't take into account climate change sufficiently carefully in thinking through the cost of development. When we do, we have to recognize it's significantly higher. A bit over a year ago, a year and a half ago now, the United Nations, in its Human Development Report, led by Kevin Watkins, came up with an estimate by 2015 of extra costs of development associated with a more hostile climate, around 85 billion a year, quite close to existing levels of aid. And that's just the extra costs of development as a result of climate change. Extra costs of development defined in terms of resources necessary to meet Millennium Development Goals. So I think we have to face up, and face up strongly, to the question of providing aid beyond the kind of targets that we've already set ourselves. And it has to be done in a way, of course, that allows adaptation and development to go hand in hand. There's not a separate adaptation story and a separate development story. This is about development in a more hostile climate, and we have to bring those investments, changes in technologies, changes in agriculture, investments in irrigation and so on. Those have to be brought together. And extra finance will be necessary. So, last two slides. What about this economic crisis, I hear you cry? Doesn't that divert people's attention? Well, it might, but only if they've got tiny minds. It's, this is a story of long-term challenge, and you have to ask ourselves, do we want to come out of this crisis by sowing the seeds of the next bubble, Just cast your mind back to the dot-com bubble at the turn of the century. We came out of that one by sowing seeds of the housing bubble 7 or 8 years later. Not a good idea. And what can we do here? Well, we can think through, not technology by technology, but we can think through broadly, what are the big growth opportunities for these next few decades? What's going to make a more attractive society for us to live in? What's going to bring down the risks of climate change? Well, it's low carbon technologies and energy efficiency. And of course, deforestation, stopping deforestation. That's how we can move quickly now, but at the same time, lay down the foundations for a much more positive growth story. That lesson, I think, has been learned. It probably could have been learned better. Very strong examples in Korea, very strong examples in China. So I do think that that part of the story is important. It's probably now becoming an old story. The fiscal boosts should already have been decided on. There's not much time for any more, but I think concentrating our minds and keeping asking the question as we think through the investment strategies over this next year or two and focusing on low-carbon technologies will be a very valuable way of coming out of the crisis, certainly much more sensible than the last route that we took. Finally, Copenhagen in December. This is the end of April, and Copenhagen is the beginning of December. Just count those months. There's not much time left. That's why it's important that this discussion is intense. I am encouraged that it is much more intense than it was a year or two ago. You've got a transformation in the White House. You've got China working on its 12th five-year plan, which starts the beginning of 2012, and you've got, 2011, and you've got the China's energy strategy as an underpinning of that 12th five-year plan. These are just two examples of the way in which policy focus has changed. But of course, those are the two most important countries. As with so many things, it's the G2, United States and China, that's of fundamental importance. But we're all involved. The EU and India and Indonesia and Brazil, the big emitters have to be centrally involved in this story, all of them. But we know roughly the scale of action. It must be at least 50% cuts globally by 2050 relative to 1990. We know roughly where to act: energy efficiency, low carbon technologies, stopping deforestation. We know we've got to embrace a whole range of technologies. We know that we have to act right across the economy, in all the way from architecture through engineering to agriculture. We've got to act right across the board. But we know roughly where and how to act, and we'll learn like mad along the way. So we know the scale of action, we know where to act, we know how to act, we know, roughly speaking, the kind of economic instruments that we need. Now, don't over-interpret no. Interpret no as we've got a good idea of a lot of those things. We know we can identify a sense of direction, and we can be pretty confident we'll learn a lot along the way. So the science is good enough to act, the technology is good enough to act. The areas where we have to make social policy, I think we can identify. The economic instruments of policy, we can more or less identify. The challenge now is political will. I see that changing, I see it moving. Whether it will move fast enough to get a sensible deal that's effective, efficient and equitable in Copenhagen at the end of the year, we'll find out. But it's in all our hands. We have to act as academics. Those journalists who may or may not be here have to think about the communication side of this. Those involved in politics have to take their responsibility, whether it's in government or opposition. And of course, as individuals, we do as well. So I think the challenge now over these next months is in very large measure a political challenge. But London School of Economics, the idea is to assemble ideas so that we're in some position to take on political challenges. Thank you very much.
Okay. Thank you very much, Nick. That was an excellent outline of the main ideas that are in his book. Very clear exposition and really compelling logic that I'm always surprised that more people don't realise that the case is as clear as that, and that really it is all in our hands, as Nick says. So we're going to move to a Q&A session now. Let me emphasise the Q bit, so when we have questions, please do make sure they're questions. Please also bear in mind that we hope that the whole of the lecture and this session will be posted as a podcast on the LSE website. We're going to go to about 8:45, after which there'll be the signing. So if you can put your hands up, when I identify you, please say who you are, what affiliation you have, and please wait for the microphone to arrive before you ask your question. So hands up, and we'll start with James Randerson of The Guardian.
Thank you very much. I don't need to do my identification bit. Thank you very much indeed for a very stimulating lecture. I've got a couple of questions. One,
we'll start with one, please.
all right. Okay. I was struck by your statement that by 2050 the rich countries would have to have a zero quota in order to, if I'm interpreting you right, in order to make up for our past sins, I assume. If that's the case, is there any way we could achieve that without technologies that actually take CO2 out of the atmosphere, or is that what you have in mind?
By zero quota, I didn't necessarily mean zero emissions. I meant that they would have no right to emit, and if they wanted to emit, they would have to buy the right to emit from developing countries, which would, for a while, have quotas which were possibly higher than 2 tons per capita. But the second part of your question is a very real one. It's going to be quite tough to hold the stock of greenhouse gases below 500 parts per million. I think we can do that, but I think that's still too high, and we'd have to ask ourselves the question of how we bring it down from there. So I do think we need to intensify the discussion of ways of removing greenhouse gases from the atmosphere. That discussion has, of course, begun. One example would be biomass with carbon capture and storage, so that as you grow whatever the biomass is, it could be anything from switchgrass to algae or whatever it might be. You absorb carbon dioxide, and then in the burning of that, you capture, so that the whole activity is net negative. Some of my scientific friends have these wonderful machines that are going to, like a vacuum cleaner, suck it all out of the air and turn it into some crystal or other. That's a friend at Columbia. I've got another friend who's already made a few billions in other activities. I'll be careful about names here, but these are real people, who is thinking about capturing carbon dioxide and turning it into cement and construction material, so we'll lay it on our roads or wherever. So lots of ideas out there about how to capture. I think how to reduce emissions, how to have net activities which are carbon negative and not just carbon zero. I would find those much more attractive than the more worrying geoengineering things of firing lots of muck up into the atmosphere to stop the energy coming in, or churning our oceans in ways that would have effects we might not understand. But I think we're going to have to think about all these things, and I would prefer if something that really worked, something that we discovered, something like these carbon negative activities, which could be, for example, the sort of biomass with carbon capture and storage. But I see no alternative but to investigating those. But we cannot bet the earth on any of these things working, and they cannot delay us from cutting emissions.
Okay, hands up, please. Let's have the gentleman in the blue T-shirt there, please.
Ed Gillespie from Futera. Just a quick question about your sense of optimism, Nick. I mean, I kind of share it. And what we've always worked at is trying to communicate this positive solutions-oriented approach to climate change, because I think it's fundamental in terms of getting the big change. I just wanted to ask you where you think the optimism comes from what the UK government is actually currently doing at the moment. And we've seen stuff in the press this morning about your opinion on Heathrow expansion and the type of things that we know are going to be the solutions, and yet everything in terms of UK government policy seems to be going in the opposite direction of the types of solutions you recommend, whether it's nuclear in terms of energy versus renewables, whether it's electric cars versus public transport, or whether it's expansion of airports. And to me, that flies in the face of the kind of logic that you so eloquently put together.
Let me try to respond on three levels. One is, what's the alternative to optimism? Another is, up to today, I haven't said anything very much about the UK. I've been trying to talk about the global story and the kinds of technologies and policies and collaboration that will allow for a world response. And then the third level is the UK. Unless we act as if we can sort this out, you might as well just get a hat and some suntan lotion and write a letter of apology to your grandchildren. The only way we can think of going forward is to try to make the best of a bad starting point. But there are lots of ways in which, and I've tried to describe those, in which we can set out to do that. So unless we set out cheerfully and collaboratively, we're going to fail. That doesn't mean being unrealistic or naive. It simply means trying to chart a course, understand the difficulties, talk them through, try practically to overcome them. I really don't see any other way. If we say, yeah, nothing's going to work, you know, the Russians will cheat, the Americans are not going to give up their SUVs, the Chinese don't care anyway, then the Brits are too lazy to do anything. I mean, I can sit in a bar and tell these stories, and have done, but that doesn't mean that they're a good basis for action or policy. And defeatism, the one way of guaranteeing to fail is to assume that we will. So I do think that that is the only way forward, and I've tried to emphasize it's global. Now, I did this morning, for the first time really, set out views on the UK, and it's 2 years since I left government, and I tried to be, you know, you're part of the story, and I don't like the idea of walking out in government and then saying that, you know, it's all dreadful, and because I don't think that's true. I do think that the climate change legislation we've got in the UK is a good model of how you can try to hold yourself account to the people of your country. Now, that doesn't mean that, you know, the legal obligation will result in any ministers or former ministers going to jail if they fail to meet the legal obligations they put on themselves. But it's a very interesting institutional mechanism in putting pressure on yourself by publicly setting targets and holding yourself to account. And I think the Climate Change Committee has shown a lot of strength and independence in doing exactly that. I think the low carbon strategy, which was launched a couple of weeks ago, makes a lot of sense, and I think it does make sense as a growth story. So I do think that we're laying the foundations in the UK for a sensible way forward, some of which actually people might follow elsewhere. The challenge now is to translate plans and targets and strategies into a coherent plan of action. And that will involve resources. It will involve a serious transport plan that takes carbon constraints and congestion and all the things and the structure we want for our cities, that puts all these things together. And I don't think you should do big projects one by one without a really coherent in transport, without a really coherent transport plan that looks at city design, congestion and carbon. So this is the kind of, we've had plenty of time to do this. We must just get on with it and do it. And we've got to be honest about the resources involved. So what we don't want is government that tries to say, well, this is going to be more expensive, and then opposition which jumps on it and says, you know, no way, we're not going to make people to pay more to go to Malaga or the Seychelles or wherever they might go. We've got to face up to the 2 or 3 decades of quite serious costs that are involved. So that's what I was trying to say. So I'm nowhere near as negative as you expressed it. I think we've got the foundations. The challenge now is to translate that into serious action.
Next question. Let's see here. The gentleman in the pink shirt at the back, please.
Firstly, Lord Stern, thank you for your speech. It was very impressive. My name's Ivan. I work in the city. Just a question. Normally, please don't throw eggs at me.
He's a brave man.
It's a brave thing to say, I know. Just a question. Often economic reports look at the counterfactual. Your counterfactual says business as usual. Is that actually the real counterfactual, given issues around food security, around famine, around potential wars and other issues like that? Is business as usual actually what we're comparing your plan with, or is it actually something considerably different to that? That today's economy as we see it is not necessarily the one we should be comparing it with. I know I've been a bit verbose, but I hope you understand my question.
Yeah, it's a fair question, but I don't think it should worry us too much. I mean, what we're trying to do is to say that to continue with high carbon growth doesn't make sense. Now, it doesn't make sense because of the damage it will do to the climate. It doesn't make sense because it can't continue because it will force up hydrocarbon prices to levels that would cut off the growth. And of course, more fundamentally, as already said, the hostile physical climate it would create would stop that story in its tracks. But we could do a lot of damage over a few decades by trying to do that. And time is very short because this is a flow stock process. And the later we leave things, the more the flows have increased the stocks and the more difficult your starting point. This isn't like a WTO story where, if negotiations fall apart, you reconvene 5 years later. Well, you've had a less good 5 years than you might have done, but you start roughly in the same position. So this is something where we have to recognize quickly that continuing roughly as we are for a while is gravely mistaken. Now, you could argue that for various reasons people wouldn't have gone on like that because there'll be a number of reasons why you wouldn't want to. And I think that's a fair comment, but it doesn't worry me very much because the real thing is what kind of strategies we should follow and what kind of route we should follow. And recognition that we can't go on as we are is an important part of that story. And there will be many arguments as to why we can't go on as we are, but climate change is a very important one.
Next question. Lady in the red top here, please.
I'm a lawyer at Google, Emma, Jenny. And my question was relating to adaptation. I was struck by your statement that there's not a separate development story and a separate adaptation story. But yet we have separate funds for adaptation. There's the adaptation fund currently being set up. There are other funds being administered by GEF under the UNFCCC to assist with adaptation. And we also have a poor history of countries actually coughing up for their overseas development aid that they pledge and then they don't pay. And so I'd be interested to know, what do you think, who should pay for adaptation? And if we merge, is there not a danger if we merge development and adaptation?
The most important thing is to try to respond to the question, what do development strategies look like in a more hostile climate? Because it doesn't make any sense to have a development strategy on the assumption that the climate will not become more hostile, when in fact we've got a good guess that it will. So the first thing is to think through the development strategy in the context of a more hostile climate, and there'll be a whole swathe of things that we have to think about. Irrigation, different kinds of crops, different kinds of transport systems that are more robust to subsidence and to flooding, and different kinds of city structures which are more robust, and so on. Insurance policies, disaster relief programs, a whole swathe of activities that would be altered by the recognition that the climate is going to change. And that's the most fundamental place to start. The second part of that story is that it will be more costly than some imaginary world, which is not available to us now, where the climate stayed stable. So it will be more costly than we had previously supposed. The third thing then is to try to raise the funds, the extra funds that are necessary. And I'm quite relaxed as to how we do that. If part of the story comes from people recognising their responsibilities, as I think they should, and contributing to things called adaptation funds, that is absolutely fine and good, and I would argue for it. But on the basis of what I've just said, the spending of those monies should be dovetailed and intertwined with development resources as a whole. If we separate those out in their administration and spending, we run the risk of confusing development strategies and development policies by trying to think of a separateness in the way those monies are used. And that's what I think is terribly important. Raising the monies, I think we can think of lots of ways, and I think the responsibility for the past is part, not the only part, but part of that story.
Next question, please. Let's have the lady in the second row there, please.
Hannah Louisos, Commission for Architecture and the Built Environment. I want to go back to political will and ask a specific question about the issue of sustainable transport and how we promote it. I discovered today that the Department for Transport in this country doesn't fund the national cycle network. Now, we all know that that's something that functions very well, and that people walking cycling not only is good for reducing emissions, but is good for them and their communities. And not only that, the department doesn't even collect data on the numbers of people that walk and cycle. Now, I was, I try and be optimistic, but I was slightly disappointed to hear that today. And I thought, as professionals, we're constantly lobbying departments to start doing the things that can be done quickly and easily, the quick wins now, like recording data, like funding the things that we know work. How can we influence that issue of political will at that department level? And obviously you've got experience of working government now, not the specifics of that department necessarily, but how do we as professionals and citizens influence that process and get change moving that can happen now?
I think there's a whole range of things. There's the basic stuff of British politics, where you write articles in newspapers, you talk to MPs, you try to persuade political parties, and that must be part of the story. Then there's the institutional fabric of our civil service, which isn't the same as the political system for good reason, and to engage directly and professionally as, for example, architects as well as citizens, I think can be very productive. I mean, my own experience working with civil servants is that they're a sensible, civilized, responsible lot, and why would you think that somehow they're completely different? And that the power of rational argument is something that's very important. Describing how things work at the moment, suggesting that this may not be sensible, doing it publicly, doing it privately, doing it constructively. I don't really know of any other way. I mean, I agree with you, and you've given yourself something to do over these next...
Thank you. Next, we've got time for one more brief question, so... We're going to...
Ricky there? Ricky better.
Rick, do you want to ask?
Ricky Burnett from the Urban Age at the LSE. Will climate change affect the rate of urbanization? And if so, is that good or bad news in terms of what you've been speaking about?
I think it will. I mean, let me answer you partly through a very specific example. When I was working on the writing of the report, the Commission for Africa, 2004-05, I was with Anna Tibaijuka, who was one of the commissioners, who's, as you know, head of UN Habitat. She's Tanzanian, but she's head of UN Habitat in Nairobi. And we went to Kibera, and I'd been working in Kenya, in rural areas in 1969, and had been revisiting really for the subsequent 35 years or so. But I hadn't been to Kibera before. And in 10 or 15 years, you'd got the creation of as difficult a slum as you could find anywhere in the world. And Anna described these people then in 2005 as climate change refugees. So I think part of the answer to your question is yes, it does make life very difficult in many rural parts of the world, and would accelerate the rate of urbanization. Now, whether we like it or not, I think that's the way I would suggest the mechanism would be most likely to function. That means, of course, that we have to think not only about adapting to climate change and making the best of a bad job in rural areas, but particularly in the design of cities, because they're going to be a more rapid arrival of poorer, destitute people in those cities. So thinking through how we design cities so that they can accommodate those extra people does in a way that's sustainable, and in a way that, both in a humanitarian sense and in an economic and activity sense and in an ecological sense, I think is extremely important. So it makes the life of you and your colleagues that much more difficult.
Well, I'm afraid that's all we've got time for in this Q&A session. So I'm sure you'll all like to join me in thanking Nick for his excellent lecture and his